Hey guys, Mr. Shed here. We're going to quickly talk about three things: plate tectonics, continental drift, and seafloor spreading. Here we go. So what I mean by continental drift is literally the continents moving. They have not always been in the same place that they are now. They were once all together in a giant supercontinent called Pangaea, as you can see here. Now over time, they slowly drifted apart over millions and millions of years into the current arrangement of continents. This graphic shows it really well, from the Permian period 225 million years ago through to the Triassic, the Jurassic, Cretaceous, and then finally the present day arrangement of the continents. Now, in order to really understand the theory of continental drift, we first have to talk about plate tectonics. Plate tectonics is the theory that Earth's crust is divided into large pieces that slowly move on the mantle. Now, plate tectonics and tectonic plates are often confused, but what we need to remember is that plate tectonics is the theory that Earth's crust, which is the outermost portion of the Earth, here is divided into a bunch of pieces, each of which is a tectonic plate. Now, typically when you see a map, you see something like this. We can see the continents, however, what you don't see is the crust that's underneath the ocean. If we were to look at just the crust of the Earth, which remember is the outermost part of Earth, we would see that it's divided into a bunch of plates like you see here. Over here we have the African plate, we have the North American plate, the Eurasian plate. I really like this video because it shows you what the ocean floor would look like if all the water was taken out. Now, the first piece of evidence that emerged is that continents' coastlines appear to fit together. Now, this is most noticeable with South America and Africa. By just looking at a map, you see that the east coast of South America over here and the southwest coast of Africa over here seem to fit together.
Both the second and third pieces of evidence that we have to support the theory of continental drift have to do with the fact that we have found identical fossils as well as identical rock structures on separate continents.
Now here we actually have a trilobite fossil from the Middle Devonian period, which was about 380 million years ago. This is actually a small trilobite fossil. They could grow up to 18 inches long and 10 pounds, so this is quite a small sample. However, based on their body structure and what evidence we do have about the trilobite, we do know that it could not have swam across large oceans. Instead, scientists hypothesized that trilobites populated an area that was once connected during the supercontinent Pangaea, and eventually, once those continents started drifting away, we had one population of trilobites on one continent, and then another population left on the other continent. Scientists noticed this with rock strata as well. Remember, first they noticed that when looking at a map, some of the continents appeared as they would fit together, such as South America and Africa. When they looked at the areas that they thought once connected, they found identical rock strata, or identical rock layers, on each of those continents. Alfred Wegener remained convinced that continental drift was true. However, up until his death, he could still not prove how continental drift happened. That was up until the 1940s when scientists started mapping the ocean floor and found what's called a mid-ocean ridge. Now, if we go to a specific part of the Mid-Atlantic Ridge, which is a part of the giant mid-ocean ridge, and go to a 3D view, we see that it almost looks like a mountain chain. Now, if we zoom out and follow it north, we see that it goes all the way to Iceland. And if we follow it all the way south, we see that it goes around the south part of Africa and up into the Indian Ocean. Now, this mid-ocean ridge is technically a volcanic feature. It's the largest volcanic feature on Earth and spans over 65,000 kilometers. Now, the discovery of the mid-ocean ridge kicked off the phenomena known as seafloor spreading, which is what causes continental drift to happen.
Seafloor spreading occurs at the mid-ocean ridge. Now, the way this process starts is that magma from the mantle rises up through the mid-ocean ridge. When it is cooled by the cold water, it turns into igneous rock. Remember, igneous rock is formed when lava or magma cools and solidifies. It falls to the left and to the right, forming new ocean floor or oceanic crust. This process creates new oceanic crust that spreads away from the mid-ocean ridge. Eventually, that oceanic crust pushes against the continents or the continental crust, forcing them outwards. The ocean floor, or the oceanic crust, goes under the continental crust or subducts under the continental crust until it goes down back into the mantle and is recycled back into magma.